I, I told you, I told you, I told you yesterday, like this is, this is sodium atom, right? It is having 11, it is having 11 protons, right? And it is having, first shell, it is having two electrons, and second shell, it is having eight electrons, eight electrons, right? Eight electrons, and in outermost shell, it is having one electron, right? So, number of protons, number of protons, number of protons, number of protons is equal to number of electrons. As a whole, as a whole, as a whole, atom is electrically neutral. Electrically, electrically neutral, right? Let him. Come in here. Right? Now, this is sodium. So, now this these positive charges are attracting these nucleus towards, there is force of attraction between positive and negative charges, right? In case of magnesium, what happens? Magnesium, this is sodium having atomic number 11, mass number 23, right? And when we talk about magnesium, so there in magnesium there are 12 protons, right? And there are 12 protons, and then it is having two electrons in inner shell, then eight electrons in second shell, right? And then they have eight electrons in second shell, and third shell they have two electrons, right? So since charge is increasing, so electrostatic force is increasing, right? So because of that, size is reducing as positive and negative charges are increasing. Charges are increasing. So size of atomic atom. So electrostatic force of attraction increasing. Electrostatic electrostatic force electrostatic force is increasing, right? And because of that, therefore therefore atomic radii, sorry, size of atom decreases, right? So you keep on moving left to right, so electrons are increasing, so size is keep on decreasing. So that's why alkali is having larger atomic size, and noble gases are having smaller atomic radii, right? नहीं तो वो वहां पे भी तो नोबल गैसेस में भी इलेक्ट्रॉन्स बढ़ रहे हैं ना। नोबल गैसेस में भी इलेक्ट्रॉन जो है वो स्टेबल है, लेकिन एटॉमिक साइज तो कम हो जाएगा ना। इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन तो लग ही रहा है ना, उससे कोई मतलब थोड़ी ना स्टेबिलिटी से। तो एटॉमिक तो इलेक्ट्रोस्टैटिक फोर्स ऑफ अट्रैक्शन इंक्रीज करता जाता है लेफ्ट टू राइट, राइट। सो एटॉमिक, सो देयरफॉर, सो लेफ्ट टू राइट in period, atomic size decreases. Getting? So this is decreases. So what problem you have in this now? So because of that, now because charge is number of shells are not increasing. Electrons are filling in third shell, right? Electrons are filling in third shell in period 3. So all the elements present in period 3 from left to right, so their electron charge density increases. Electrons are increasing in outermost shell, and protons are increasing in the nucleus. So electrostatic force of attraction is increasing, so their atomic radii is decreasing, right? This is the way you have. Fine. Okay, should I rub this? Okay. Oh. So yesterday I made a table, right, like this. It was having group and it was having periods, right? Today I will make very small table, right? Not go so much uh, periods and groups. So this is period 1, right? So this is period 1, right? And then we have period 2, right? Period 2, and like this. And now we are having groups. This is group 1, this is group 2, this is basically D block elements, right? This is D block elements, D block elements, right? These are D block elements. And then we have group 13, Then we have group 13, 14, 15, 16, 17, 13, 14, 15, 16, 17, 18. Right? This is. So in this, elements are. Oh, ink is overflowing, man. It's not khatam nahi ho rahi. Overflowing. So this is like this, right? So we have first group, we have hydrogen, atomic number 1, it is electronic configuration is 1, and then we have helium with atomic number 2 and it is having 2. And after that we are having lithium. Lithium is having 3, it is 2 comma 1. Then we have beryllium. Beryllium, that is atomic number 4, so 2 comma 2. Then we have boron, that is 5, that is 2 comma 3. Then we have carbon, that is having 6, that is 2 comma 4. Then we have nitrogen, that is 2 comma 5, right? And oxygen, that is 2 comma 6. And then we have fluorine, that is 2 comma 7. And then we have neon, that is 6, 7, 8, 9, 10. This is 2 comma 8, right? This is. So as I told you, atomic radii decreases. Atomic radii decreases. Atomic radii decreases, right? This much we have studied yesterday, right? So now some few things are also there. That is that is you know one thing I would like to discuss with you just for sake of your knowledge. You know how electrons are filled, right? So there is a Aufbau principle for that. That is 1s2. Then we have 2s2. We have 2p6. We have 3s2, 3s2, 3p6, 3d10. Then we have 4s2, 4p, 4p6, right? 4s2, uh, uh, 4p6, 4d10, and then we have 4f14, and we have 5s2, right? So electrons filled like this, right? Like this is the way how electron filled. Like first they go in s2, then they come back and again comes to no, it's not like this. It is like this, that first 1s2 it is going, right? uh, hmm, एक- like this is 1s2 na, this is 1s2, then it is going 2s2, then it is going 2p6, and then they comes to 3s2, then they come like this and they go 3p6 and 4s2, right? Here up to calcium fixed, here up to calcium, right? 20 electrons are there. Calcium is having electronic configuration atomic number 20, and it is having 2 8 8 2. So first shell में 2 इलेक्ट्रॉन, सेकेंड शेल में 8 इलेक्ट्रॉन, थर्ड शेल में 8 इलेक्ट्रॉन, एंड फोर्थ शेल में 2 इलेक्ट्रॉन, राइट? After that, what happens? After that, they goes into like this. They comes to in 3D, right? They come like this, 3D, which is not in your syllabus. That comes iron, cobalt, iron comes in this, copper comes in this. Iron is having 26, right? That comes, iron is having atomic number 26, right? And then zinc is also is there like this. So this is happening, so this is not in your syllabus right now, but this is how. That's why we are only discussing up to carbon, sorry, calcium. Beyond calcium, then we go d block element, then we need this, right? And for lower elements, what we have done, like number of shells in the lower elements, number of shells number of shells represent represent you know number of shells represent uh, period, right? If there is one shell, one period, two shells, second period, third shell, third period, right? Like that. It is having fourth shell, so it is in fourth period, right? And 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 number of electrons, what happens, man? Number of electrons, number of electrons, number of electrons in valence shell represent represent group, right? So it is having one electron, so first group. Lithium is having one electron in valence shell, so it is having first group. It is having two electrons in valence shell, so second group. After that, d block elements come, and third, if three electrons, then it goes to 13th group. Fourth electron, so 14th group. 5 electrons, then 15th group. Then 6 electrons, 16th group. 7 electrons, 17th group, and keep on going, right? So this is the benefit of modern periodic table. With the help of electronic configuration, you can know about their position in the periodic table, right? This is, you have modern periodic table. Modern periodic table, right? This is, I gave you a brief about how electrons fills in different energy shells, right? First fill in lower energy shell, and then they go for in higher energy shell, right? So now I'm going to rub this, right? Now just 4 topics which we have to discuss more here. Should I rub this now? So now you can get the position of an element. You can find the position of an element in a periodic table, right? Number of shells and number of valence electron, right? With the help of number of shells and valence electron. Now we have there is a term which we call ionization potential. ionization potential. Ionization potential. What is that? Ionization potential. Right? Ionization potential क्या होता है? It is amount of energy, amount of energy required to release an electron from atom in its gaseous state. In its gaseous state. Gaseous state. That is called ionization potential. Right? So, like sodium needs how much? Like sodium, there is a sodium atom. There is a sodium atom, right? You gave it energy, right? And then it is giving you Na plus one electron is coming out, right? So this is equal to ionization potential. How much energy is required? That is known as ionization potential, right? How much energy is required to release an electron from from atom in its gaseous state? That is known as ionization potential, right? I hope you understand. Should I have this? So actually, what happens in left to right in a period? You see, electrostatic force of attraction is increasing, right, among the electrons and protons. So nuclear atomic radii is decreasing. When it so for releasing electron, you need more energy. So ionization potential also increases from left to right in a period. क्योंकि as much as electrostatic force of attraction is there, as so more energy is required to overcome that electrostatic force of attraction and to extract electron, right? Similarly, for and top to bottom in a group, what happens? What happens? It is having one shell, it is having two shell, so releasing electron is quite easy. So ionization potential is decreasing. Outermost cell is having less impact of electrostatic force of attraction offered by nucleus, right? Releasing electron is easy. So ionization potential decreases from top to bottom in a group and increases left to right in a period. What I said? left to right left to right in period increases, right? And top to bottom, the top to bottom in group decreases, right? This is we have ionization potential. Should I rub this? Okay. Now we have another, that is called electron affinity. Electron affinity, right? Electron affinity. Electron affinity. right? So that is amount of energy वहां पे क्या था, अमाउंट ऑफ एनर्जी रिक्वायर्ड, है ना? जस्ट चेक इट आउट व्हाट यू रोट. No, what was written in electro ionization potential, what I told you. That I told you, na, that was energy required to remove. Here, amount, amount of energy released, released on removing, removing an electron, removing an electron from atom, from an atom in gaseous state. Gaseous state, right? So ये क्या हुआ, amount of energy released on removing an electron from atom in gaseous state. Like we talk about, say there is a oxygen, right? uh, Oxygen, right? Yeah, we can say releasing, removing, like chlorine. Chlorine is having 7 electrons, right? So when we remove an electron from it, so we have, it needs high amount of energy. So it turns to be, when you remove an electron, then it gets positive charge. Sorry, don't go for chlorine. You come to, boron, boron, right? So it is having 3 electrons. So if it gets plus one charge, 1 electron it loses, then it releases some energy, right? And electron is coming out, and electron is coming out. So this is known as electron affinity. Electron, energy is coming out. This is energy, and this is called electron affinity. Electron. I hope you understand these two terms. Electron affinity मतलब जैसे क्लोरीन है तो क्लोरीन will have high electron affinity, right? Because it has less tendency to lose electron. It is having always in uh, it is always in a mood to get electron, right? लेकिन lithium, beryllium, boron, they have a tendency to lose electron. So they lose electron and also releases energy, right? So that is we have about electron affinity. So these two terms are very important. Ionization potential, electron affinity, right? And as I told you, electropositivity is decreasing from left to right in a period, and decreasing and increasing top to bottom in a group. And electronegativity increases from top to bottom in a group. Top sorry electron electron sorry Electronegativity increases left to right in a एक मिनट electron electronegativity increases from left to right in a group and decreases top to bottom in a period. period, in a period, right? Left to right is always left to right is always period, and top to bottom is always group. So in a group, electron and electronegativity decreases, and in a period, electronegativity increases from left to right. Right. So this is also what more terms are given to you. This ionization potential IP, then electron affinity, and what else? Atomic radii I told you, electronegativity I told you, and what else is given to you? I told you yesterday, and electron affinity. Electronegativity, you know very well, है ना? Tendency to lose electron, tendency to take electrons. So fluorine is having high electronegativity, and lithium is having high electropositivity. They have a tendency to lose electron, and because so lithium is having metallic character, and fluorine is having non-metallic characters. Right. So this much you have about your periodic table. You come to know how to find out the groups, or a group or period of an element in a periodic table, right? The number of shells representing periods, right? Number of shells is representing period, and number of valence electron is representing group, right? If there is one electron, first group, second electron, two electrons, second group, three electrons, then 13 group. Because D block elements are there, 10 D block elements are there, because of for that we leave the purpose. We leave the groups, right? So this much I hope in your first chapter. All the major topics I covered in this. Is it okay? Okay.